Now, if you are searching for a capacitor, and you can typing in this value, you'll be getting a capacitor, and you can choose anything if you want, and you can place it. Close. And again, if you open the component, so now you can see here there are a lot of groups, and each and every group will be having their own components. If I'm selecting source, so from here I can choose an voltage source, a current source, a digital source like clock and all, and power source regarding what you will be giving for transformers and all. So now as I've selected this family, if I type capacitor, for example, the listing won't be available here. That is because you have chosen a respective family, and the components which are available under this family is only the components which are particular for this sources alone. So when you are in all groups, and now you can find the, so here I can also search for resistor, and I'll be getting a resistor list. So this is very important when sometimes if you're typing the respective component's name or with any specification exactly, if you couldn't get it, first check this place whether it is selected correctly or not, and then you can move on. And as I said, this is one place where you can find the component list, or the shortcut is Control W, or you can choose it from here also. So once if you choose it, for an example, if you're trying to do a full wave rectifier or a half wave rectifier, simple things are like normal XOR gate, NOR gate, and you're verifying the truth table. If you're opening it, you must be knowing the list of components, what and all is required exactly for you to execute the experiment and to get the output. So once if you open this component list, you can choose everything. So as I said, this particular place will be helping you directly go to the respective family. For example, if I go to basic components like resistor, capacitor, transformers, switches, everything will be there. So if you want any other components from the power source, if you want to place a voltage source or a current source, you have to change this to either source, or if you know the name of the product exactly, you can go to all groups. So this is the possibility. And once you open this component list, select what and all components you want. So for an example, if I'm placing this, okay, I'll place a resistor now. And then again, this dialog box will appear. So choose whatever you want. So now I'll go for a voltage source. So it will be giving me some voltage source, whatever I require, or else anything if I am taking inside. Voltage control, capacitor, anything. So I'll place this also. And once again, it will open. So finally, when you want this dialog box to be closed, you can either select this or you can also give this. So that is when your component list will get closed. The reason because once if your design is ready, if your design is ready on your paper and you're going to execute, and you can try your and check your output alone. So this place will be helping you to pick out all the components at a single time, and you can place it wherever you want. So last time what we saw is half adder and full adder and a half subtractor. So this is your experiment. So this is how your components will look like. Okay. Now you can observe here, I have given a 5 voltage as an input, and I've selected switch. So the purpose of this switch, so then this switches might be single pole single throw switch, or a double pole single throw switch. So whatever you want, depending upon the need, you can choose each and every component, or when you know the usage of a particular component, use that. So where this will be available? Go to basic, switch, select it from here. Or else, if you are given any multisim program, so if you are given any particular multisim program and you don't know where is the component is exactly, select this component, right click, go to properties, and display, Sorry. Okay, I'll tell you that later. So when you click on, you can go to properties, then you'll be knowing where is the component exactly present in the component. I'll let you know that later. So this is how your structure will look like. So from the half adder and the half subtractor, so you know that A plus B is A XOR B, and for carry it is A and B. So XOR gate is going to give you the sum, and the AND gate is going to give you the carry. At the same time, in the place of these two, this is for the difference. So you can here see that the same A XOR B will be giving you the difference, but one input noted, that is inverted, and multiplied with the same input will letting you help you to get the borrow. So if you have your truth table, open your design. First, let's pick changes to all groups. The reason because why I'm starting with the half adder full address. So this experiments will be very easy and it's known to everyone. But at the same time, it's very comfortable choosing and picking up the components for the first time. And after that, it'll be easier for you to monitor next things and all. Pick your resistor. So how many resistors do I want? I need 2. So I'll place it here.
5.
Why do you need 5 resistors? See
To
here.
create.
Sorry, my okay. See, you need 2 resistors and 2 switches. The reason of the resistors is just to cut down if there is any purposing of high current when flowing through it. So it will stop it. So this is exactly how you can see in the replica of the hardware time, and you can check it over here also. So next is I need switch connection. Fine. So when you place a resistor like this, what will happen is that will be uncomfortable for you to connect the switch also. So you can rotate it clockwise, or you can give control R, which will help you to rotate. And next what you want to do is go to the switch, select basic, go to switch, select the component. If you don't
Sir,
want
your voice not audible, sir.
no.
Not
Also,
audible, sir.
disturbance, sir.
Yes, sir.
It's clear only, sir. Clear only, sir.
Yes, no, I don't know, because some people their voice is also breaking. I don't know.
Yeah, sir. Now it's clear only, sir. Your voice is clear only.
Okay, ma'am. So I can give control R, and if you want to
Is
select
that
this or
clear?
sorry.
Sir, you continue, sir. It's clear only,
Okay.
sir.
Okay, listen. So once the switch has been placed, if you want the same switch to be selected again, copy and then paste it. There's also this option is also available over here. Control C and then again Control V. And now if you want, you can move this, place it here. And the connection of wires is direct from one terminal to the other terminal. and from this place to this place. And then what we need more is the power source. Then now go to the sources. DC power is fine. Select this, place it. And next what we need is ground. Select it, place it over here. Okay. So now we'll finish this part and then again we can compare. So what I have used here, selected here is a 12 volt. If you want to change the value of the components which are here, for example, I have chosen a resistor of 1 kilo ohm. If you wanted to convert it to 10 kilo ohms, value here, take mouse, double click. So here you'll be having the option called value. If you wanted to change it to 10 kilo ohms, enter 10, give OK. The again, if you want to bring it back, select it. If you want to give 1 mega ohm, select it and use. So now what I do is I'll just go to 1 kilo ohm itself, that itself it's fine. And 12 volts is exactly needed. You can choose 5 volts. So there's no option space. You can give in whatever values, and then take a wire, connect it to the last terminal. The reason because is there you can directly create a junction to make your picture look clear, that you will also learn automatically. But still, if you connect over here, from here you can take one more wire. So from this part you have to take one more wire, but it is very difficult for you to integrate it exactly. And then what you have to do is you have to do it like this, which is unwanted. So first of all, for the clear wire connection and for better understanding, connect it to the last poles. If you know very clearly like where your wire is going to end, connect it, and then from here again establish a connection. So for this case, also it's the same. Connect it here, voltage is supplied, and the common ground is given. Okay. Next, what is needed? Your gates. See here. Now this part is over. Next, what you want are the gates and your display output. Now again go to place component. Now if I'm typing XOR gate, will I be getting the gate? No, because it's in different family. You can either go to basic, you'll be getting, go to other products, Miss Digital, you may be getting it, or the best is go to all groups. So once you select all groups, your all the list components will be available. Type XOR. So once you type in, it will be asking you 3 and all is 3 input XOR gate, 4 input XOR gate and all. So now what we need is a 2 input XOR gate. Select it and then place it. Next, what we need is a AND gate, which is also a 2 input AND gate. Select it and then place it here. Okay, let's close this. So once if you finish your experiment, you are very sure like you don't need these values and all. You can change this to A and B, resistor R1, R2, which is not needed. It is 2, you can change it to B. A input B, and you can have this. You can move this values here, which is not needed. Right. So now everything is fine. So how to establish connection from where to where? Check it over here. So that is why I'm showing you the circuit diagram, because if you know also, you can also try the same thing. One is to the A part, another one is to the B. A, and next one is to B. So from here to A, next one is to B. Okay. So finally, to check out the output, what you have to do is you have to select probe. Give Control W. Okay, 1 minute. I don't know what's happening over here. Right. See here. This was not first available. Now, if a multism experiment or a multism program has been directly given to you like this, you don't know if there is any unknown component which is not known to you. Select the component, right click, go to properties, and here you will be knowing where exactly the component is available, where MISC Digital TAL. So now let's open the component list. So here, yeah, 1 minute. There is master database, MISC Digital, and TAL, and the manufacturer is generic. So this is where you'll be getting your output. If not, you don't want to go to this option. Select this, go to replace components. So this will be exactly telling you where the component is, and you can find out, okay, it is in MISC Digital in the first place, and you can choose the option directly. So these are the two methods where you can find the components. So from here, you can go to the MISC, and then from here you can find out the digital value, get the data exactly. So this is how you have to start your connections. And then finally what we have is we have to looking out for the probe. So probe will be available in the output part. So here we can go to all groups. The reason because the method to type in and get the components is easier than searching in each and every one. So here when you check, you'll be getting the probe where you can choose different colors. So now I'll take green color for addition and blue color for carry. Now I'll connect this. So make it very sure the probe needs at least 2.5 volts. So it should be above 5 volt or sometimes 12 volt. So this will be confusions what you'll be getting it. Experiment it by changing the values. Check out whether you're getting the output or not. So in this place, you can directly type in X1, go to label, change it to sum. And this one, carry. And after completing this, you have to run the program. So this is where you have to run it. Once you run the program, carry. Is it clear? 0, 0, there's no input. And for 1, 0, and for 0, 1, everywhere sum is on. And when you give both the inputs, it's 1 and 1. Your sum will be 0 and your carry will be 1. Clear? So before stopping the program, uncheck all your switches so that once you start, it will be starting from the first value. So this is a very simple experiment to find out where the components will be available, how you can choose your components, and how you can run your experiment. So this is for the half adder. As we couldn't check out each and everyone's program, I'll be asking you to execute this program first and then try this half subtractor also. So for this, when you have the design, select the components, Control C and give Control V, place it here, you'll be getting the values. Okay. So now what you can do, same A input, B input. So here, as I said, in the case of borrow, you need an inverted input. Okay, fine. I'll connect this first, A and B. So now select this wire, right click, Okay. Sometimes there are some problems. Okay, fine. So next is you need an inverter. You can also type in as NOT gate or as an inverter. So whatever you want. NOT gate. Place it here and then close it. This NOT gate has to be connected to the in terminal A and other one to terminal B. Change this to borrow. Difference. So now if you run it, you can observe the same values. Same value as the truth table. So now we can check out. So this is how you have to compare the values, check out for each and everything. So for 5 minutes, I'll display you the diagram, for the circuit diagram. Check this, and the next we can move on to the next experiment. So when you place any extra components, click on the particular component and then just give delete. That's it. See if you're this, if you don't want this component, select this, give delete. If you don't want the component, it's undo, Control Z. Give that, it will appear automatically. Okay, now let's move on to the next one. So it's the same extension of the half adder. Here we have the full adder. So what is the difference you can see here is there will be an extra switch. This full adder is a 3-bit input circuit. So you'll be having one more input. So S1 is A, S2 is B, and S3 is C. And the same connections like resistors, power. So here you can see the input. So here you give chosen 10 ohm, here I given 5 volts. So that is not going to make a big difference at all. And then the usual connection. So these connections are basically based on you from the equation what you got from your K map. So solve your K map, try to get the equation because it's, for this equation is everyone know. For what will be the is AB in BC plus CA, and then that is going to come. And the next one is going to be the ABC bar with an XOR gate. So it's very simple. So if you're not very sure regarding the equation, check it in Google, or you can design your own K map, find out the equation, solve it, and then draw your circuit. So that is how everyone will start doing the experiments when you're starting your digital electronics first class. So that is going to be the same principle. So the experiments what we are seeing here are very simple because these are going to train you how to choose your components, how to develop your own circuit. But after that, if you're strong in electronic circuits, papers, analog electronics, and then this will be more easier, useful for you to perform your own experiment, find out what is the output when you want to developing your own product or anything. Can be very useful. See, still now regarding the patent of full ladders and in the full ladder component, 8 transistors are used, which got reduced from 31, 30, and now it's 28 transistors if I'm not wrong. Even if you reduce, if you can reduce one transistor, one single transistor, that is actually a biggest achievement. So for these things and all, you can use this experiment, this multisim pages or anything. I'm not forcing on you have to use this alone. So the purpose of this using this, you can try to import this in hardware component exactly using the same design, and you can check out how it is going to help you. So that is also a possibility. If anyone can do that, that will also become a patent for you. So those kind of helpful things which is possible using these softwares. So to understand this, it's very easy to work on with it. If you know the circuit, try and work on with your small intricacies like giving input, how is the output will work like for triac, SDAC and all. Learn about it for Schottky diode, for 555 timer. Everything will be there. You can conduct n number of experiments using this. Learn it and start doing the experiments. That's it. So regarding the full adder, it is very simple. You have to extend your switches S1, S2, and S3, and then finalize it. Any doubt in these two experiments? Okay. So next, we can move on to the half-wave rectifier. So I have circuit, but what is the difference here? Is a capacitor here, because we are going to see half-wave rectifier with filter and without filter. So without filter, you'll be exactly getting the sine wave, and one side is removed. And in the case of with filter, you'll be getting a different waveform. So now let's check out one by one. So which is very simple. Diode and your peak voltage. Any mandatory you have to give this alone. So for an example, as I said, go to a replace component, you can here. Anything you can use. So I have used in here a voltage source. You can also go for a power source, giving because that also will be having the voltage. So it is not mandatory you have to select this alone. Try the different in every family and then choose the diodes. So now you can see here. Okay, I'll show you in the last experiment in this design. I'll remove this subtraction part. You can choose, select the particular wire, change the net color. The reason why I didn't teach you here is, you can see it here. Simple experiment, voltage source connected to diode, and it's connected to the resistor, grounded. Okay. Now the next important thing what see here is, I'll open a new page. The component list here. So now you can see here you have a multimeter. Once you open it, it will be give the values for current, voltage, or resistance, whatever you want. Then a function generator. Instead of a voltage source which are getting it from the power source, clear one. Anitama, my voice is clear.
Sir. Yes, sir. Sir, clear, sir.
Okay. Okay, ma'am. Okay. So function generator, you can so see from the function generator, you're having wave, wire, angle, and I'm sorry, a normal sine wave, angle, and a square wave, and you can change the frequency also. So whatever if you want. So you can either use your power source as a voltage source as an input, or you can use your function generator also. Not an issue. Next, you'll be having a watt meter. So here you can see oscilloscope. So this is where you're going to observe your output. So what I've chosen here is a 2-channel oscilloscope. You also have a 4-channel oscilloscope also. So like that, you'll be having different component list to display the output. For example, a Bode plotter. What is the purpose of a Bode plotter? You can check out the cutoff frequency after designing a circuit. So which one? Low pass filter or a high pass filter, you can use a Bode plotter to check out what is the cutoff frequency, has it been meeting it exactly with your cutoff frequency or not. Frequency counter. So what generator is for digital logic analyzer. So logic analyzer, most of the products will be studying what is called a logic analyzer and network analyzer. So here you can actually find out the help of what is a logic analyzer and network analyzer. So you are on using for Xilinx, you'll be seeing it on the output, like how your output is varying. So this will be helpful in generating and seeing you the output exactly. How does each and every component works? And see, you're also having a network analyzer and Agile multimeter. Okay, so this depends on each and every component. And see, so here you have the LabVIEW instruments. So from this design, you can either using a you would have studied for what is called a what is it called, a case I'm sorry, not a case structure, grouping of elements. So after grouping each and every element, what are an example? For example, if you want to take a half subtractor, half adder, you can group all the elements taken directly into LabVIEW. So as of now, this is not there for you, so I don't wish to cover that. So here you can start choosing your components for your input as well as for your output. So that is how your half-wave rectifier has been designed. Chosen a voltage source and a diode is picking up. Go to all groups, type in diode. So you'll be having different diodes. You can choose it if you want. PN junction is also there. Zener diode also you can choose. So here I have chosen a normal diode. I have placed it. Now after placing the component here, I'll delete this. My first terminal A will be displaying me my input signal. 1 minute. My input signal, and my channel B will be displaying my output. So I'll first take this connected, and my two negative terminals of my oscilloscope are grounded. I can either ground it here, or as I said, we can delete this wire, take it from here, connect to this port also. So no difference is going to happen. So let it remain the same. How to search the components? When you know the name of the particular component, what you're going to use it directly, go to place, component, and then type it. That is what I said. When your option, when your family has been changed to any one of this, that is what I told you. If you have selected basic, here the components available are these components alone. In under basic family, if you search for a voltage source, you won't be getting any voltage source at all, because the voltage source will be available in source family. So here you can see a signal voltage source, signal current source. So for that, make it very sure you have always selected the option all groups. So once if you search for any component, for example, NOR gate or XOR gate, whatever, you'll be getting your component directly. Fine? Any doubt in this? Okay. So as I said, my A input will be, my A terminal will be displaying my input, and my B terminal will be displaying my output. Okay. Now I'll run you the program. I'll show you. Okay. You can see the output. To make it very clear, what you can do is like, choose any one of the wire, either input or output. Right click, change the segment color. I'll give blue. Now it has been converted to a blue color. Now after I run my program, so now you can see my inputs will be in red color and my output will be in blue color. If this is not very clear, hold on. Yeah. So this is your input. The red color is your input and the yellow color is your output. So you can differentiate your output on the channel by changing the segment color. So here also we can do the same. Now we can see the output for this one. See here, this is your filtered output. So the left one, the oscilloscope one is displaying you the filtered output, and my oscilloscope 2 is displaying you my rectified output. So both are rectified, but here you can see the filtered output. So for this, you'll be knowing the theory, what is exactly happening behind this, why it is getting filtered. The filtering is because of the capacitor, because of the charging and discharging. And that is what, and that is why we have connected here a capacitor over here. I'm sorry. The capacitor is placed and the same circuit connection is given to this. So what change you are going to see it in full adder? You'll be using a bridge rectifier and your input will be with your transformer. Like you can use a transformer, you can either use directly your bridge rectifier and connect it to your input signals, your voltage source. If you're using your transformer, there's need of only 2 diodes. If you're not using transformer, you can go for 4 diodes, where your middle 2 input diodes will be grounded and the other 2 input diodes, the other 2 diodes will be used for your input and output display. Any doubt in this? So once your trial is over, as I said, you have to change your system's time or your computer's time, PC, anything, whatever you're using, a laptop or PC, whatever. Change your time. Change your date to something like if you're in 2020, okay, if you're starting 2021, give your date to some February, March 2020, and then start using it. And then it will be your trial version will be extended, because what you're using is not, it's original software, but it is not activated. So you have to use this type only, or else when, okay, so before explaining the other things and all, is there any doubt regarding the experiments what you have seen? See here, this is for the half wave rectifier. The full wave rectifier, it is also there. But this I don't want to show it now. We'll see it in the next class, because I wanted to try. And before next class, I will check with your ma'am regarding how many of you have submitted or how many of you have drawn your full wave rectifier and checked your output. And after that, we can start. Or after that, we all can sit and design the same circuit next week. So your full wave rectifier with or without filter, that is your wish. Refer Google or your old textbooks, draw the circuit, see your output, and then just discuss with your teacher, and next week you can see like how many of you have got the output or how many of you didn't get it. Okay, of course the values is very important. That is what you have to use your calculation. For an example, if you want 1 kilohertz as you in designing a low pass filter, if you want a 1 kilohertz as a cutoff frequency, what will be a component list? You'll either choose your resistor or capacitor as fixed, and then you change your values, because your frequency is equal to 1 by 2 pi of the component. So here also you'll be having calculations and values which you can observe. When you change my resistance value to 10 kilo ohms, what will happen? My output reflection will, my reflection, it will be reflected in my output. So this you have to choose. That is where you have to directly use your calculation, your old formulas, and then compare it with the theory you have studied. Because these are very simple. Move on to quite difficult, but on conducting the experiments it is okay. So make sure you are very strong with the theory, and that is why it will be useful for you to do the experiment. So whatever software you're using, theory is very important. Go through all your formulas, which are the only for the list of components, list of experiments is this. So after above this, I'm not going to discuss anything extra. So just go through or revise your formulas regarding these experiments alone, which will also be shared to you, and then try concentrating on doing the experiments. And only homework what I'm going to give you is the design full wave rectifier and then see it with or without filter. That is your wish. Okay. And for any doubt, I'll give my mail ID. It has been given in the chat box. use this. Any doubt regarding installation, just send me a mail. I'll get back to you with the most probably within a day. Okay. So any doubt for today? Okay, regarding the installation, I have uploaded the person whoever asked. I have uploaded the link. Click on the link. It will be taking you to the NI website page, ni.com. So here you will be having the option called download. So this once you download it, there will be an exe file or a zip file, whatever. Unzip it, try to install it. But while installing that software, you need internet. Whenever there is some lag in it, there will be some problem. So there is for that, you can go for this individual offline installer, which will be around some 900 MB. That's all. Download this and put it install, and you can do whatever you want. So that and for any case, it will be asking if you want to participate in the update program of NI. No, give OK, and then will be useful. Okay. So regarding using the consistency, it's very simple. This wire, so now I have two, that is, one is my output, another one is to compare my output with my input. So there is no need I have to go for a 4-channel oscilloscope. I'll go with a 2-channel oscilloscope. I'll place this. A terminal is going to display me my input. I can also assign it to my output. That is your wish. I'll assign B to input. And this negative has to be grounded. Now if I run my program, once you click on this oscilloscope, both the input and output will be in the same color. What will be the color? The red color. So to make it very clear, I'll choose this. I'll select this wire. Right click, go to segment color, choose any color I want, and now the wire's color will be changed. So it is not actually the wire; it will be the signal's representation over there. Run it, and you can see. Change the time division. So whatever you want. This time division will make you very clear. So the reserve you have to use it. If you want it single, it will be stopped for one single time. When you give none, it will be running it for continuous time. DC or AC, that you will learn in each and every time. If you give AC also, so here there will be no issues. So you can see the difference over here. So understand what is the purpose of giving AC voltage, DC voltage. Study that, you will know one by one. So regarding the link, you have to check the teacher. She'll be helping you for that. Okay. Okay. Anita ma'am. Hello.
Yes, sir.
Ma'am, so we can end the session for today, ma'am.
Okay, sir.
Okay, fine. So thank you, everyone. Any doubt? Contact me in your mail. I'll reply you within a day. Thank you.
Thank you, sir.
Thank you, sir.
Stop.